Okay, there's exactly one exponential function that goes through any two given points if the points are either above or below the x-axis. Both points have to be on the same side of the x-axis. Okay, so we want to find the unique exponential function through the two given points. Turns out that's actually pretty easy to do. So, now I said find the unique exponential function, but an exponential function is just a y equals b to the x. It doesn't have a vertical stretch factor. So I got to say find the unique vertically stretched exponential function through the given points. General exponential function with a vertical stretch is y equals a times b to the x. So what we want to find is the function y equals a b to the x that has value 1 when x equals 3 and value 4 when x equals 7. So we want to find a and b such that y equals ab to the x satisfies the equations. Okay, y is supposed to be 1 when x equals 3. So 1 equals a times b to the third. Okay? And this says that y equals 1 when x equals 3. So here, y is 1 if x is 3. So this and this are identical if y is 1 when x equals 3. Not exactly identical, but okay. Then you get y equals 4 when x equals 7. So you get 4 equals a times b to the 7th. This is a set of two simultaneous equations in two unknowns. Okay? And the unknowns are a and b. There are various ways you can solve these equations. You can solve for a. You get a equals 1 divided by b to the third. And then you could plug that into the second equation and get your solution for b. To give you an equation in b. And we're going to do that. Another way is simply to divide one of these equations by the other. And that's the first way I'm going to do it. So we can solve for a in the first equation and plug our expression into the second equation. Or in this case, we could divide one equation, finish the word there, equation, by the other. Okay, well, I'm going to do this first, and then I'll do this. Okay, so to solve, let's divide the second equation by the first. Okay? Now, when we divide an equation by an equation, that means we divide the left-hand side and we divide the expression to the right-hand side. So we get four over 1, because that's the left-hand side of the second equation divided by the left-hand side of the first. And since 4 equals a times b to the 7th, and 1 equals a times b to the 3rd, that's the same as a times b to the 7th divided by a times b to the 3rd. Okay, well, we simplify this. Okay, the left-hand side just becomes 4. The right-hand side, and I'm going to write out details so we don't just cross out symbols. Right-hand side could be written as a divided by a times b to the 7th divided by b to the 3rd. Now we know that a divided by a is 1, and 1 times b to the 7th over b to the 3rd is just b to the 7th over b to the 3rd. And of course, b to the 7th over b to the 3rd is b to the 7 minus 3. Another way of writing that, of course, would be to say b to the 7th is b to the 4th times b to the 3rd, and you're dividing by b to the 3rd, and you can separate out the b to the 3rds. You have 1 in the numerator, 1 in the denominator, to give you 1, and the result is going to be b to the 4th. Either way, 4 equals b to the 4th. So b to the 4th raised to the 1/4 power equals 4 raised to the 1/4 power. B to the 4th to the 1/4 is b to the 4 times 1/4. Four times 1/4 is 1. So that's just b to the 1 equals 4 to the 1/4. And that's just b. It turns out that I just happen to know that because the 1/2 power of 4 is 2, and the 1/2 power of 2 is 1.414, something everybody in my generation knew back before we had calculators. It's the square root of 2, and that can be determined. But in general, you're going to use a calculator because you're not going to get something with a known value. Now, I didn't plan for that to come out with a number I could actually approximate the 4 significant figures. So in general, I would have to get an accurate result, I'd have to resort to a calculator. I did a pretty good job of estimating things in my head, but if I wanted it to be accurate and reliable, I'd have to use machinery. Either that or do a big long Taylor series, and I'm going to do that. Okay, so Of course, 100 years ago when I was in school, we had big tables of numbers. And it's basically logarithmic tables that allowed us to do these approximations with a reasonable amount of arithmetic. Okay, well, that illustrates one way of solving this problem. Another way of solving it solve for A and substitute, meaning we can solve for A in either equation. Okay, so we have the two equations. We solve the first equation for A. We get A equals 1 over b to the third. Plug into the second equation. It's 4 equals a times b to the seventh. If a is 1 over b to the third, we're going to subtract, or we're going to substitute 1 over b to the third for a, and we're going to get 4 equals 1 over b to the third times b to the seventh. Well, 1 over b to the third times b to the seventh is b to the fourth. And that's totally equivalent to what we got over here. So the rest of it, I'll just say etc. It just follows all these steps come over here. Okay, well, this is a general way we can find an exponential function through two given points. So now we know our function is, I didn't complete the solution. Okay, I was satisfied when I got down here and got B, but I've got to now find A. Well, let's go ahead and find A here. A is 1 over b cubed. So that's 1 over 4 to the 1/4 cubed, which is 1 over 4 to the 3/4 power. So now we know what our function is. We've got the value of A and we've got the value of B. Notice that either way we solve to get the value of B, of course we get the same thing, and then we can plug that back in to either equation to get the value of A. Since I'd already solved the first equation for A, I just used that solution with the value of B. Had I plugged 4 to the 1/4 into, let's say, the second equation, B is 4 to the 1/4, I would have gotten 4 to the 7/4 here. I'd had to divide 4 by 4 to the 7/4, which would have given me 1 over 4 to the 3/4. So generally I plug this back into one of the equations. We'll do more examples and you see that, but now we can say that y equals, I'm going to write it out, 1 over 4 to the 3/4 times b to the x, that would be 4 to the 1/4 to the x. So y equals ab to the x these values of a and b gives us this, and that's approximately equal to, now you're going to make me do the reciprocal of 4 to the 3/4, which is reciprocal of, turns out to be 2.818, and the reciprocal of 2.8 is going to be between 0.4 and 0.33, a little closer to the 0.33. So I'm going to say it's approximately, and of course your calculator would give you a number for this. You run these numbers in your calculator, you're going to get approximately, I would say, 0.37 times 1.414 raised to the x. What's the graph of this thing look like? Well, it's an exponential function that goes through these points. We can get a third point. If x equals 0, 1.414 to the x is 1, and we just get 0.37. So if this is 1 here, which it is because this is the 0.31, 0.37 is a little more than a third of that. So I'm going to say 0.37 is about here. And now we can draw an exponential function type curve. Looks a whole lot like the 2 to the x curve. Matter of fact, it's identical. No, I'm not going to say it's identical, but it's a compressed or expanded version of the 2 to the x curve. And there it is. So what you need to see is, if you've got 2 points, if you know the form of the function, you can substitute the y and the x for each point into this form, and you get 2 equations. If it's an exponential function, you can always follow either this method or this method for solving it. Okay, solve one equation for a, substitute that for a in the second, and you have an equation that just has b, as we did here. Then solve for b, just taking the appropriate power of both sides. Evaluate it if you need to do that. To take the exact value of b, then, and plug it into one of the 2 equations and solve for a. Once you put a number in for b, you have an equation just for a, and you can easily solve it. Okay? So, alternative to that method is, you can always divide one equation by the other. The a's are going to divide out, and you're just going to get a power of b equals some number over here. And that's what we did here. We got the same thing we would have gotten this way in this step, and we can easily solve. In either way, we can plug the value of a into one equation and get the value of b into one equation, and we can get the value of a. Okay, so you see there's some algebra steps here we're probably going to want to talk about. This is, well, how do we know to take the 1/4 power of both sides? Are we comfortable enough with the laws of exponents to understand totally what's going on with this step, for example? Are we comfortable enough with the rules of algebra to correctly divide one equation by the other, or to correctly solve one equation for a, plug the solution into the other? Okay, so we're going to see that because you're going to have an assignment Monday that asks you to do that. Okay, we'll go on in a minute.